you click on the link provided to you. Right, so with indifference analysis, we do not have to measure utility. We don't have to assign a pound sign to utility or call it a util. You remember last time we had a hard time in understanding how we measure utility, and I said it was a hard time for all economists how to measure utility as well. So we avoid that, and indifference analysis allows us to choose between different combinations of goods, where we don't have to measure utility again, and it involves ranking combination of goods according to our preferences. Okay, so these are the key points here, and introductory points. But we'll do a little bit of maths again in this case. So let's get started. We assume that the consumers can decide whether they prefer a combination of goods to other combinations of goods. So take an example of this. If you were asked to choose between two baskets of fruits, each containing different combinations of oranges and pears. So one basket contains 4 oranges and the other contains 3 pears. And in one basket you will have 4 oranges and 3 pears. In the other basket you will have 2 oranges and 5 pears. If I ask you which one you prefer, you could tell me I am indifferent between them. You know, I can choose either of them, or I prefer one or the other. That's the indifference analysis. Very simple indifference analysis, because you are indifferent between the two of the sets in case you get the same utility from consuming 4 oranges and 3 pears and from consuming 2 oranges and 5 pears. Does that make sense to you guys, what I just said? You would be indifferent if you, by consuming 4 oranges and 3 pears, get the same utility as when you consume 2 oranges and 5 pears. So these two baskets would be providing you with the same level of utility, and we are not going to measure utility anymore now. We are not going to ask ourselves, how much is that utility for me worth if I consume 4 oranges and 3 pears? Instead, we compared with another set of the same goods. So that's indifference analysis in its very, very primitive form. But we will give it a more meaningful definition in a minute. Right, so aim of the indifference analysis is to analyze the preferences of the customers, or how we decide as rational consumers what to buy and how to buy, without looking at the utility itself, without measuring it. Like the example given to you doesn't measure the utility at all. It doesn't give us, or it doesn't ask us how much utility we get from 4 oranges and 3 pears. It could be that we prefer both of the either of the baskets, given that they give us the same amount of satisfaction, utility. So we do not have to measure it at this moment. So let me give you a multi-point example now. It's the next slide. That gives you more, that provides more context to the introduction now. For that, however, we have to derive an indifference curve. And indifference curve shows all the combinations of two goods for which we are indifferent, or by consuming these combinations we are indifferent at any point. So in other words, 30 pears and 6 oranges gives me the same utility or satisfaction as consuming 6 pears and 20 oranges. So these combination of pears and oranges, or we label them as points, give us the same level of satisfaction. That's our starting point. So let's assume that these combination of goods, A, B, C, D, E, F, G, labeled as points or baskets, you can think of them as basket. So basket A contains 30 pears and 6 oranges. Basket B contains 24 pears and 7 oranges. And I am indifferent between the 2 points. Basically, I am happy to consume either of them, and either of them give me the same level of satisfaction. Right, so what does it look like if I draw these points, plot these points on a graph where my vertical axis is the unit of pears that I consume, and horizontal axis are oranges. In this graph, point A gives me 30 pears and 6 oranges. Point B is the combination of 24 pears and 7 oranges. And I am indifferent between the 2 points. So if I were given a choice to choose between A and B, I would choose the same. I would choose any of them, because any combination will give me the same satisfaction. It's just when I moved from A to B, I just sacrificed 4 units of pears to get 1 unit of extra oranges. So along this curve, any point along this curve gives me the same level of satisfaction. So that's the indifference curve that economists usually use to analyze preferences. Well, we combine it with budget line at some point, but for now, does this make sense to you guys? Is it clear? It has a lot of different uses. I mean, if you plan to do economics, intermediate level or advanced level, indifference curves are useful. But this is a starting point. But these are actually very simplified versions of real complexities. We usually in real life, we don't have two units of 2 good types of goods. We also always have multiple types of goods. To analyze multiple types of goods and utility, then we have to use differential analysis or differential techniques, derivatives. But that's what you do in masters in economics at some point. Is this clear, guys? How we construct the utility, indifference curves? Yes, no? So along this red line, any point gives me the same level of utility, and all these points show me or reflect the combination of goods that give me the same level of utility. Clear? Yes? So that's indifference curve, that's good. Now you might ask, it's actually bowed inwards, right? The graph is bowed inwards. You know, it's bowed towards the origin. Now you might ask, why is this? Well, this is due to the topic that we studied last time, diminishing marginal utilities. And if you did the problem set, you may understand now by now what it is. But let's define it now. The slope of this curve basically gives the rate at which the consumer or we are willing to exchange one good for another one, and holding our utility or satisfaction level constant. In other words, as I said earlier, if I go back to this green line or blue line, at any point on this indifference curve, my satisfaction is constant. I have the same satisfaction, but I have different combination of goods. Yeah? And notice what it is. To measure the marginal rate of substitution, which is also the slope of this curve, we'll use this formula. And I think I have to graph this now. Marginal rate of satisfaction or substitution declines over time and over different combinations, because we usually move from up down, from top downwards, from the top of the graph downwards. And marginal rate of satisfaction is change in y over change in x, mathematically. So let me draw something there just to give more detailed explanation on this. We said that the MRS is the slope of this curve, and that stands for marginal rate of substitution. And the formula for it is change in y over change in x. Okay. Now we also said, so it's good y, good x, oranges or apples or pears we call it. We also said that the reason it's bowed inwards, like pulled inwards, it's not a straight line in other words, is because of the principle of diminishing marginal utility. Now, when we have lots of one good, lots of one certain good, consuming the next unit doesn't give us the same utility as when we consume the first unit of that. So extra consumption of the same good gives us diminished marginal utility, lower marginal utility, right? It is clear. So the first unit gives us large amount of utility, second unit gives us slightly smaller, and so on and so forth. So as we consume more, we derive less and less utility. Now, notice that to move from, so let's say at this point here, we have 10 of good Y and 2 units of good X, so you can call it oranges or pears if you want. And at this point here, we have, let's say, 3 units of good X, and let's say this is 7 units of good Y. What we are doing is now, again, we bring back the context. Between point A and B, I'm indifferent because they give me the same level of satisfaction. However, to move from A to B, I am sacrificing 3 units of good Y. So I am giving up 3 units of good Y to get 1 unit of, just 1 unit of good X, right? So I am happy to give more of this to get just small amount of that. So this ratio, as a result, will be a high number, right? Because the Y here, change from this to this amount will be, let's say, 3 here. And change from this to this will be 1. Obviously, this is minus 3 because Y1 is greater than Y2. So we get a negative 3, but we take always absolute value, so marginal rate of substitution 3. Now, that implies what the 3 units give me the same amount of utility as 1 unit here gives me. Because I'm just trading this off. Yeah? I'm substituting 3 units of that I give now with this. Now, the reason is why there is a large, why the slope is large here at the high levels is because I already consumed so much of that. I'm already possessing huge amount of this. So I'm happy to give up more because it gives me less utility than this. X. So just to get a small amount of, initial small amount of X, I'm giving a large amount here. Because my marginal utility from consuming this is less than this one. So if you measure the slope here, what's this now? To move from point to point here. So let's say this is 4, this is 1. To move from this point to this point, I'm actually now giving up more of this because I already consumed more of this now. I'm increasing the consumption of that, so I'm happy to give up more. My marginal utility from consuming extra of this is diminishing again. So now, the change here in X is larger than the change here. So if you divide a small change by a large change, gives you a lower value. So marginal rate of substitution is declining. That's why we call it diminishing marginal rate of substitution. As we switch between the goods, we're happy to give up more of the higher consumption that we already have. Yes?
Why are you taking the positive for the first one and for this one? Negative.
Okay, this will also be negative. It's just I take the thing, absolute value. Yeah? The marginal rate of substitution usually gives a negative value because this is still declining. It won't be flat. It is still declining infinitely. Yeah?
What application? Like, how could you use that? Like, how is that beneficial?
It's not beneficial in reality, except for utility, preferences, or when you have more of one thing compared to other one, that's less. To get the 1 unit of the thing that you have fewer, you are happy to give up more of that other one that you have more of. If you have more money, you are happy to pay more because you have more of it anyway. in exchange for certain goods. But if you're poorer, you don't want to spend, more money on certain things. So you can apply it in your real life as well. However, this, if we carry on doing it now, and if we hopefully we have time, we come to the budget lines where this would be useful. Yeah. So this basically, in reality, has very sort of little economic implication, but it is actually a psychological topic. Behavior of the consumer is actually a psychological study. But economists borrowed that from psychologists to analyze consumer behavior. Think about the gold and water example. Sorry, diamond and water example. If somebody wants to give you a gram of diamond, how much water would you be willing to give him? Okay. Just a gram of diamond to get a gram of diamond. This is going to be so much, isn't it? Water is so cheap. That's because we already have so much of water here and little diamond that we acquired. For that, to just get 1 extra gram of diamond, we just happy to go down so much. I mean, if you think of that size water, this is diamond. Yeah, this actually tells you something about reality as well. We're just expressing that realistic assumption or realistic case in mathematical form. But life is not composed, consumption is not, of course, always composed of X and Y. You have many, many more. So decisions do affect. Because when you're exchanging 10 tons or 10,000 liters of water with just a gram of diamond, you have to really think about your family, neighborhood, and and things, especially in Saudi Arabia. When you go there, it's probably more expensive. So it's rare. Depends on how much we already have, where we are on this point, on which side, yeah? So in this case, we have lots of Y, so we're happy to give out more. While in this case, at this point, we have less of X, we're not that happy to give. So just to get a small amount, we're happy to give out more of the Y, yeah? But as we move along, we actually acquire more of these. So the utility we gain from that extra unit of X now is diminishing. So as a result, the curve slope will be declining as well. Okay, hopefully that the math side is clear. If the math side is clear, the rest will be clear to you as well. I will set more of problem sets for these as well. The problem set I uploaded and you are doing now is actually for the last class. For this class, I'll upload more. Right, so this is what we have just done. So you see, just to obtain 1 unit of orange, extra unit of orange, we are happy to give up 4 units of sacrifice, 4 units of pears. And applying the formula, change in y over change in x, we will have a -4, which is now absolute value will become 4. We always take the absolute value, ignore the negative sign. But later, as we consumed more of x and less of y now, giving up really just to get an extra unit of x now will not be taking extra 4 units of y, because we already have less of y left now. So we don't have much pear anymore. So the extra unit of orange now is going to cost us just 1 extra unit of y. Yeah, opportunity cost of y is now, x is now declining, because now we have very little amount of y while we have huge amount of x. So this principle leads us to the idea of marginal rate of substitution, diminishing marginal rate of substitutions. Yeah. Okay. I have just explained this. It's in writing. When you're independently reading it, please take a look. So I'm going to skip this. And we will now link marginal rate of substitution, the mathematical term that we have just discussed, change in y over change in x, to marginal utility concept. Notice that what we are doing here, to gain 1 unit of oranges, we are giving up 4 units of pears. So that means marginal utility we get from consuming oranges must be 4 times as high as that we get from eating pairs. Does that make sense to you guys? Because we are exchanging 4 units of pears for 1 unit of oranges, it must be the case that one orange gives us 4 times as high marginal utility as that we can, as when we get when we consume 4 units of pears. Yeah, is this clear? So we now link that MRES to the term marginal utility. So it's basically the slope of this indifference curve is now marginal utility of x over marginal utility of y. So it's a case of trading off between two goods. Okay. Now, indifference maps. Now, at any point here, this is an I1 indifference curve, a hypothetical one with good x and y. Any point along this curve gives me the same level of constant satisfaction. I2 does the same. It gives me, any point on I2 gives me the same level of satisfaction. But the satisfaction I get from combination of goods on I2 is different from the combination of goods lie on I1. Now, the satisfaction I get from the combination of goods that are on I2, I3 now are even higher. So let's go back and repeat what we just said. I1 is an example of an indifference curve along which lies different combination of goods, x and y, which give me constant level of satisfaction. I2 does the same. Any combination on the I2, any combination of good x and y gives me the same satisfaction along the curves. I3 the same. However, the level of satisfaction I get from I1 is less than I2. And the level of satisfaction I get from the combination of goods that lie on I3 is higher than I2 and I1. So this is just a map of indifference curves. Does that make sense now? Just a map of indifference curves that give us, as consumers, different combination of goods x and y that give us different levels of satisfaction. But along the curve, the satisfaction is the same. But over different curves, the satisfaction changes. Higher the indifference curve, the higher the satisfaction that we receive from consuming the goods. Is this clear, guys? Or do you want me to draw you out this and pieces here to show you further to explain? Yeah. So let's do this. Let's see if I can get the. This is I1, I2, and you have oranges. Yes. Point A, point B. Now, on I1 lies point A and B, and at point A, I have 10 units of pears and 2 units of oranges. That's a basket A. If you think of that basket A in the shop. And then at point B, I have 2 units of pears and 10 units of oranges, for example. It could be 12. Now, consuming, because A and B lies on this indifference curve I1, the satisfaction from consuming this bundle is the same as the satisfaction I get by consuming this bundle. So let's say I1 is equal to 10 some utility level. Let's not use a number here because we usually don't, with the indifference curve, we don't say it's utility or counts, but it just gives us some absolute value 10 level of satisfaction. Now, on I2 lies a point A prime and B prime. The satisfaction I get from consuming a bundle that is 10 units of pears and 3 units of oranges will be the same as the satisfaction I get from consuming 3 units of pears and 10 units of oranges, because they lie on the same I2 level, indifference curve, yeah? Point B prime and A prime. However, satisfaction I get from consuming A is not the same as the satisfaction from consuming A prime. A prime is higher, gives me higher satisfaction because it lies on the higher indifference curve. The same here. The satisfaction I gain from consuming the bundle of fruits in B prime is higher than the bundle of fruits I consume from point B. Yeah, because it lies on the higher indifference curve. So higher indifference curves give us higher satisfaction levels. And in both of them lie different combinations of various combinations of goods and services. If you can think of this as a service, that would be a service as well. Any question on this now? Yeah? Okay. So this will be interesting when we add the budget line here as well. Hopefully it will be interesting. So this is the indifference map. You could draw indifference map for different combinations. In other words, you can think of this case as a person getting richer. As the person gets richer and richer, or their budget increases, they would like to really be on I5, the highest utility level, yeah? That provides the highest utility level. But they are indifferent between any points that lie on I5. However, they prefer points lying on I5 than points, 2 points lying on I4, given that they provide the high level of utility, and the I5 provides the high utility. Now, question is, you could ask, will the indifference curves cross? If you think of the two indifference curves, do they cross at all? Do they intersect? Like a point A here, and then you have this. Consumers cannot be indifferent between A and both B and C. Now let me draw this on board again. Probably you don't understand. Probably it's clear now to you guys, yeah? Why we cannot be on A, B, and C and have the same utility levels. Right, so let's go X and Y, some goods. Then we have our indifference curve 1 and indifference curve 2. So this is I1, this is I2. And at this point, these graphs cross A. Now, point A, the combination that is 7 units of this and 5 units of Y, lies on both of the indifference curves, doesn't it? Because they cross. That point at this intersection is on both lines. So effectively, we can expect this, indifference curves to have the same level of satisfaction. So in other words, the point here, B, and point here, C, should give me the same satisfaction as a point A. Because point A is on I2, point is also on I1. Since point A is on I1, satisfaction I get from consuming point A combination should be the same as point B combination. And then, since point A is on I2, satisfaction that I get from consuming A point combination should be the same as the point C combination, because it's also on R2, right? But we said indifference curves that are higher, that lie higher up, will have higher level of satisfaction. That means B should give me less satisfaction than point C combinations, yeah? In that case, it doesn't make sense to have equal satisfactions at any point here. So that must be the case. So they shouldn't cross, they should intersect. Because if they intersect, we should have a case where utility from A is equal to utility from B, and from B, utility from B is equal to utility from C points. But as we just demonstrated, they cannot be. Yeah? Because point B has a different combination of groups, but then at the same time it lies on I1. Point C has a different combination of groups and it lies on I2. And I2 is higher up than I1. As a result, they do not provide the same level of satisfaction, not a constant level of satisfaction. So I2 could be 30 level of satisfaction, while I1 could give us 20 level of satisfaction. But 20 utils you can forget if you want. It's just they do not cross. Yeah, the consumers won't have cannot be indifferent between A, B, C, basically. Yeah. So if a test asks you a true and false question or something like that, just remember this idea that A, B, C cannot be equal, given that utility curves that lie higher above entail or command higher utilities, or indifference curves entail or command a higher level of satisfaction. Okay, now we superimpose the budget line into the utility line. So far we've been talking about people's preferences and their being indifferent between any points on that lie on a certain specific indifference curve. However, in reality, we always are constrained by income. So we always have a budget to spend. I might say I'm indifferent between 10 diamonds and 15 gold combination, and then the 30 gold and 1 diamond combination. But I'm constrained by my income. Gold rings, I mean, not just gold itself, gold rings and diamond rings. Yeah, I'm constrained by my income. So I need to find a point where my budget line intersects with my utility curve, such that it gives me the highest utility given my budget. So that's what we're going to do now. But let's introduce first what budget line is in the first place. So budget line shows the combination of goods that is available for consumers given their budget and given the prices of the goods. And again, we look at the two good combination, two good case where having the third good here will make sense, because in reality, when we make a decision over to purchase certain goods, we also think about purchasing many other goods. If I spend on laptop, well, I have to now find money for this and that and those. So lots of different aspects, different factors that we have to consider. But we start with the simplest case of too good again. Let's look at this table just before we start drawing up. Is anyone copying? If you're copying, let me know, because I could, without realizing you're copying, I could switch. And however, by the way, these slides are available, plus I'm recording as well, so these are available online on YouTube channel. So if you missed today, well, in the sense that not miss the class, just something happened and you just missed a few points, then you are welcome to watch them. So let's go on to this budget line case. Look at this case now. You have two tables. First table shows us the combination of goods given our budget we can purchase. Unit of good X and unit of good Y. Given our assumption about budgets. Notice that we have a price combination here. Price of X is £2 per unit of X. Price of Y is £1 per unit of Y. It could be oranges and apples, you call it, you name it yourselves. But we only have budgets amounting to £30. So we can spend £30 on two goods. Now go back to the first table. First row shows you a combination of X and Y, where with our budget of £30, we can buy 30 units of good Y, but no good X. We can buy 30 units of good Y because good Y is £1 each. So if you divide 30 by £1, gives you the number of goods that you can buy. So in this case, if you spend all your cash on buying good Y, you will have 30 Y but no X. Now look down further to the last, look at the last row now. There you can see that if you spend all your cash on buying X, then you can only buy 15 of them because each one is a £2. So 30 divided by 2 is 15 units, yeah? And no money is left for buying units of Y or good Y. And in between the two extremes, you have different combinations. Let's say if you buy 5 units of X, well, each unit of X is £2, so you spend £10 on that, and remaining £20 will be spent now on good Y, which gives us 20 units of good Y, given the price. Now, if you plot these combinations on a line, on this XY plane, that gives us this long red line, downward sloping again. And notice that the shaded area is not available for us given our budget. We cannot really buy any combination of goods that lie on the shaded area. But we can buy anything inside the area, below the red line, or on the red line. If you buy any point on, let's say you buy a point here, let's say you buy a combination of 10 Y and 5 good X, you can afford it, you can purchase it, given that £30 budget, but you are not spending all your cash. So on the red line, you have the combinations of goods which require you to spend all your cash. Just like the product, remember the production possibilities curve? Being on the curve is being efficient, utilizing all your resources. Similarly, being on the red line, any point on the red line means you spending all your cash. And the combination here, having 20 units of Y and 10 units of X right at this point is not possible, given that we only have £30 to spend. If you spend all your cash on buying Y, 20 units, well, it will be £40, right? Sorry, £20. So you only have £10 left for buying X, and you cannot really buy 10 units of X, given that this is only, it's quite expensive, £2 each. Now, is this clear, guys? How budget lines are constructed? It's very simple, right? So if you go over this again, point A is a point where we spend all our cash on buying good Y, nothing from X. Point B is the second row, point C is the third row, combination, so 10 units of each. And last point is when we spend all the cash on buying good X. Now, question is, what happens to the budget line if our income increases? Guys?
Shift to the right.
Yes? Shift to the right, yeah? Because now we are able to buy a bit more. Yeah? So it will shift to the right. It's a basically parallel shift, right? Let's assume that our original budget was £30, a new budget will be £40. Then, given the prices, we are able to buy, if you spend all the cash on unit Y, then we are able to buy, on Y's, when we are able to buy 40 units of good Y. While the price remaining at £2, if you spend all your cash on X, then we can only buy 20 units. So 40 over 2. That's good. Right, so getting richer for now. Now, next, what is the slope of this line? How do you measure the slope of a straight line? Yes?
Gradient.
Yes, gradient, yeah? What's the formula for that? So let's put it on the board here. Do you remember, Maria? What's the slope of the gradient? Oh, sorry, of the line. Gradient of the line. From your algebra. Martha, what do you remember? So how do you measure the slope of this blue line? Well, you just have to tell me because you know it. You just don't want to tell me. So what's it? I heard it, so yours gets no, I want to ask others as well. Gradient formula for measuring the slope. The straight line.
1 over b or something?
Sorry?
1 over b.
1 over b. That was when you had the function, right? So what was it? Do you remember? Just anyone? How do you measure straight lines gradient? Any straight line doesn't have to cross here, but any straight line.
Is it y equals m plus b?
Y
equals
equals?
brackets
That's a full function, isn't it? We're looking at an equation, just an equation. Anyone apart from him? We raise your hand and I'll ask you. Yes?
Isn't it like y1 minus y2 if you work out the same line?
So it's a change.
Change in y and change in x.
Yeah, that's the gradient. Yeah. So slope of a straight line is change in y over change in x. That's like we had earlier, right? So remember, change in y, was y2 minus y1. Change in x was x2 minus x1. Now what do we have here? 15. This is 0. This is 30, right? Using this formula now, let's find the slope of this budget line. Slope of this budget line is y2 minus y1 over x2 minus x1. Then what is our y2? So this was y1, y2. So this would be 0 minus 30 over 15 minus 0. x1, x2. Right? So minus 2. And we usually in economics, again, we deal with positive values, right? So slope is 2. Now, divide price of x by price of y. Divide price of x by price of y. Gives you the same result, yeah? So in economics, the slope of budget line is the price of x over the price of y. Doesn't change, yeah? So we just applied this math, simple math in economics, and it does make sense now, yeah? Next question. Oh, sorry, next now. So we figured out what it is. Next is effect of, now, so we looked at the effect of income change on budget line. Now let's look at the effect of price change on budget line. Look at the small table there. It shows us assumption change. Here now, price of X not £2 is not £2. Now it's £1. So it declined, while price of Y remained £1 now. Given our budget of £30, how do you think our new budget line looks like? What does it look like? Shift or swing or whatever it does. What do you think? So you need to just calculate now extremes of spending all your cash on Y and spending all your cash on X to get the shape. Yes?
So then the whole line doesn't shift, it shifts at an angle. To the
Yeah. You meant to the right because X.
X decreased from 2 to 1.
Yeah. So how many units of X can you get now if you spend all your cash on X?
see. Okay.
So it swings to the right, yeah? Because now price declined. If you spend all your cash on X now, you can get 30 units of X, not 15 when the price was 2. So it just swings to the right or pivots around point A basically, if in this case, yeah? Okay, and we already defined what the slope is. Slope is this formula, price of X over price of Y. In our original case, the slope was 2. In the new line, the slope is now 1. 1 over 1 gives you 1. Yeah? You can also use this formula as well. 0 minus 30 over 30 minus 0 for the new curve gives us 1. Yeah? Now, we have a problem here to look at, so let's see if we can solve it in the next 1 minute. So somebody would like to come and draw it for us on the board. I'll clean the board for you. You want to do it?
I'll try.
Yeah, okay, let's ask how to do it. Now you'll do it, but let's before we show, it's better for them to get time and have a time, have their time to do it and then understand it the way they understand. Then we can explain. Independent work is very, very important for you guys, especially for exam. You need to be able to make decisions independently. You know, sometimes we get the result, we are not confident, so we just cross over. And I saw this sort of case in test 1. Student got the result correctly, crossed over, put the wrong result. So that his hesitation really is because they probably didn't do practice properly. They didn't do enough practice. That's why these problem sets are very important. Before I review the solution, you do it yourself and then compare. So you need to have that sort of hesitation removed from. Who wants to come and do it? Oh, sorry, have you done it, please? Done it? That's good. 1. We have 2 students confirming. 3 students. Okay, let's see the answer. So we have the pen. You can go and show the proper points.
I'll just draw the first budget line.
You mean the original budget line?
Yeah.
Yeah.
Choose. Stays there. Drops down to 10.
Yeah. Do you think correct?
Yes.
Yes. Yeah. The curve became flatter. Yeah. When it is flatter, the slope is also lower than 1. So basically, how he did is this. You could see easily back at the extreme values. So originally, in your budget line, you could consume if you spend all your cash on Y, you could consume 30 units and no X. But because now the price of Y has risen to £3, if you spend all your cash on that good, you end up only eating 10 units of that given the price rise. While price of the X stayed the same, so you have the same original units. So that connecting the 2 units will give us the new budget line. And in between lies all the amounts that you can spend on combinations you can spend. Now, keeping the original curve there, do this one as well. what happens. So I'm going to clean this now. So I'm going to get rid of the new line, but we start from original point. And somebody hopefully will help us. Again, what happens when it's doubling? One thing, by the way, before I forget, it's possible that you may not have the first class after you come back from your break. If I manage to sort this out, the problem that I'm facing now, we will have, but I will let you know 1 week ahead at least with the class. If I cannot fix it, you'll have to cancel that class and I'll give you extra problem sets to do on these topics so that it will help you for your test too. So we'll cover it. But I will give you eventually the solutions as well. But I will let you know whether there will be class on Tuesday when you come back or not. So just trying to tackle this now. It's a personal issue. It has to be done on Tuesday. It at least 3 minutes. But we will have a replacement class. I reserved one extra free class basically to week 13. That week 13 doesn't have any class. If you look at your syllabus, you will see that I left it for spillover material like this, class cancellation and all this. So we will have that replacement class. So we will have enough time anyway for the whole learning objectives to be covered. It's just I was thinking in week 14, week 13 we will not come and you prepare for your exam, but then we will have actually proper revision then, in class revision. Okay, so who wants to do it? Who wants to show us the solution? Someone else now? The answer is very interesting, isn't it? You got same. But everyone is smart. It's the same, isn't it? Yeah, when your income doubles, and at the same time prices double, you will still consume the same amounts, don't you? Just divide the new budget by the new price, X, and new price of Y. You get the same quantities. So some people say, okay, my income is increasing, I'm getting wealthier, but usually salaries are raised consistent with the inflation rate. So really we still are in the same level of consumption that we did in the past. Now this happens to me. My income is rising by a very, very small amount. And if I look at the inflation, the prices that goods are raising, inflation rate, it's also rising. So it appears my employers so far have been paying higher salaries, but consistent with the inflation rate. It doesn't meet the inflation. So I am still poorer, as much rich as I was in 2012 when I compare that salary to today. I'm still earning, well, in terms of real earnings, like in terms of number of goods I can purchase, I still purchase the same number of goods. Yeah. Egg prices are rising, bread prices are rising. So 2% increase per year on my salary is actually matched by average 2% increase in my rent and all these expenses I have. So I am still at the same poor person as I was in 2012, even if I see that the rise is there in my income, but that rise is actually offset by the rise in prices. So that's a good example. So is this clear, guys? If not, let me know. I'll draw it myself on the board. Well, obviously there's nothing to draw. You just divide the new budget, which is £60, by the new prices. And you will see that you will still be consuming 30 units of Y and 15 units of X. So this line, the budget line stays the same, just doesn't even shift if they occur at the same time. Now, given that we all want to be off on this indifference map, we all want to be on the highest level, highest indifference map here, highest indifference curve in this thing. We would like our budget to cross or to be tangent to the highest of the indifferent curves, given our income. So, I mean, if we didn't have that problem of income constraint. If we had that rich daddy, rich inheritance, huge amount of wealth, we would probably consume goods on higher and higher indifference curves in reality. However, as we said, we have constraints, and that's a budget constraint. So we cannot really spend everything that we have. I mean, we cannot spend beyond everything that we have, beyond the wealth that we have, right? So if we superimpose the budget line into this indifference map, we will be able to see where our optimal consumption should be. If I label them, so that's the budget line, and there's a point T at which my budget line is tangent to the indifference curve 3, I3, but also at the same time, my budget line crosses two other lower indifference curves. Now, point V, I get a level of satisfaction, and I still spend all my cash on combination of certain goods at point V. But point U gives me higher level of utility than point V, given my budget. Because that level of satisfaction is within my reach, given my budget. But if I look further, I could get even higher satisfaction if I consume point T, consume combination of goods at point T, which are Y1 and X1. So this must be my optimal consumption point, given that it gives me the highest level of satisfaction given my income. Make sense, or do you want further explanation? Quite?
It's clear.
It's clear. How about others? So basically, remember when we just draw this line, any point is possible on the line, any combination of goods are possible. We can buy any combination of goods, spending all our cash. But the task is to find the optimal point. Should I consume this much of X and Y, or should I be on this point, A or B? Which is the best? I still don't know. The way to find is to superimpose budget line into the indifference map. And then we have to find the point that lies on the highest indifference curve. And in this case, T lies on the highest indifference curve given my budget. Of course, I want to be here on this line, I5, on the I5 curve, right? But my budget doesn't let me buy this combination. It is clear. So it's the constraint that keeps me to stick to a lower line. So this is I3, which gives me a certain amount of satisfaction. But consuming a bundle of goods that lie on indifference curve 4, will be even better. However, given that I have limited income, I can only be on I3. I could, of course, be on I2 if I want, and consume that much. But I2, this point here, gives me less satisfaction than this point. So I'd rather be here until my next income rise comes and no price changes. So then it will be the next curve where I get the highest satisfaction. Clear, guys? This is the burden of macro. Lots of drawings, lots of maths. But as you independently study a bit and then watch the video once again, it will become even clearer. Now, what is the slope of indifference curve at this point? That's another question we want to answer. What is the slope of indifference curve at this point? What's the optimal level slope, basically point? Well, we know it that at point T, point T lies on the straight line, that budget constraint. And what was the slope of the straight line, the budget line? It was Px over Py. Since point T lies on I3 as well, we know from before that I3 has a slope which is marginal utility of x over marginal utility of y. So at that point then, since both curves intersect at that point then px over py must be equal to mux over muy, yeah? So at that point, the slope of marginal utility, indifference curve will be mux over muy. Yes. Done. Right. Any question on this topic? Any question? So y1 and x1 is the optimum combination of consumption. I will set an